Hi guys, we have this question is a simple supported beam ABC, and it is carries a distributed load which is maximum intensity is W naught, and we have the span of the length is L, this L. So determine the maximum displacement of the beam. Displacement, that means the same deflection. Okay, so we have deflection like this. Of course, the maximum deflection is going to be at the midspan. So this one is maximum deflection, which is at mid span of the beam. Okay, how can we find the deflection? To find the deflection, we know the first step is to find the reaction. To find reaction, we have RA equal to the RC. Why? Because it is symmetry, and equal W naught L over 4. Why? Because you see this triangle, we have two triangles, this one and we have the second one. Okay, so for this one, the resultant is going to be the area of this triangle. The area of this triangle is W naught, this one, W naught, times the distance L over 2 times 2. That's going to be RA. So RA W naught L on 4. And RC is going to be the same, W naught L on 2.5. So RC is W naught L on 4. After that, we're going to find the second one. The second step is to find the moment equation. How can we find the moment equation? I'm going to assume the x-axis. So you see here, y-axis, and this one is x-axis. Okay. So because it is symmetric, so I'm going to take just half of the triangle. So to take half of triangle, this one, okay, so we have this is x. How can we find the moment? So to find the moment, I need to cut here, correct? To cut here, we have R1, which is W naught, or RA W naught L over 4, and then we need to find this resultant. How can we find this resultant? Okay, so just I'm gonna continue this triangle. I'm gonna put the triangle here. Okay, so this one was L over 2. This is W naught. I'm gonna, because I'm cut here, so this is x. I need to find this y. This y is gonna be equal to, so I'm gonna say y on x is gonna be W naught L over 2. So y is gonna W naught 2 W naught x over L, which is this, correct? This is y. So because we have y, I'm gonna find what? I'm gonna need to find this, the resultant of the triangle. The resultant of this triangle is gonna be y, this y, times x divided by 2, okay? Which is y times x divided by 2. So y times x divided by 2. How much y? This y, which is 2 W naught x over L times x on 2. 2 with 2. So it's going to be W naught x square on L, which is this one. W x square on L. So we cut here at x. So we have just moment. To find this moment, it's going to be reaction W naught L over 4, this one, times the distance, which is x, this one, minus this reaction, this force, which is W naught x square on L times the distance from here to there is x over 3. Then arrange the equation, we can get this reaction, okay? After that, this one EI. So after that, I'm gonna say EI y double dash equal the moment. Integration, oh, first integration, second integration. Now, we need to find C1 and C2. So from the symmetric, you see from the symmetric, the first boundary condition is at x equal to the 0, y equal to the 0. Here, we have y equal to the 0. So from here, you can get C2 equal to the 0. Second boundary condition is dy over dx, which is equal y dash equal to the 0 at x equal to L over 2. Here we have slope equal to the 0 at L over 2. Then we're gonna put, but in this case we're gonna use this equation for y dash. I'm gonna put this one is gonna be 0, and instead of x I'm gonna put L over 2. Then we can get C1. So the answer for the answer sorry, yes. So we have two, as we said, we have two constants. We need two conditions. The first condition, it is y equal to the 0 at x equal to the 0. Then you can find c2 equal to the 0. The same condition is dy on dx equal to the 0 at x equal to the L over 2. Then we have this equation for dy over dx. Instead of x squared, we're gonna put L over 2 is gonna be square. Here we're gonna be L over 2 power 4. Then we can find C1. C1 is gonna be this equation, this value. Then I'm gonna put C1 in the original deflection equation, which is in terms of x. The question is, I need the maximum displacement at midspan. So of course midspan, that means x equal L over 2. So how much y at x equal to the L over 2? Just change x by L over 2. And we have, this is x squared, L over 2 squared, x power 4, L over 2 power 4. So the answer is going to be this one, negative W naught, L power 4 divided by 120. This negative, that means the deflection is going to be down, which is correct. Okay, this is the answer.